Hello, my name is Bob Willis and welcome to Defect of the Month. Now, printed circuit solderability. It's something that I've been looking at for, well, pretty much all my career. We started off with tin lead as a coating on a printed circuit board, and that was used as an etch resist as part of the PCB fabrication process. We then looked at solder leveling to allow us to apply solder just to the pads that we wanted to solder on the printed circuit board. So there was no solder underneath solder mask which would wrinkle during reflow and wave soldering. We then had the option of gold over nickel. Then we had copper OSP. We have now something that's very popular within the automotive industry is tin finish. And we also have silver as a process finish on boards. And engineers need to look at each of the different finishes and determine what's right for their particular application. I'm a great fan of copper OSP used in the right applications. It can be a very good and very reliable surface finish. But again, you need to check and see the quality of the OSP coating and the surface preparation from your PCB supplier. Coatings like that can deteriorate quite quickly if the assembly process is not run correctly and it impacts on the quality. If we look at tin, initially when you have a board with tin finish, in terms of solderability, it is very, very good. However, it doesn't necessarily stand up to bakeouts. It doesn't necessarily stand up to multiple reflow operations before it deteriorates in terms of wettability and solderability. When we look at nickel gold, it's pretty flexible because it will stand up to multiple reflow and secondary assembly operations, provided that it's a good quality finish. Like all of these finishes, the finish needs to be assessed and determined to be correct for your particular application. So some of the types of failures we see with different finishes is poor or slow wetting. We can see complete non-wetting of pads. We can see de-wetting, where the solder initially wets onto the surface, then draws back away from the pad, which gives us perhaps an unacceptable solder joint. We can see issues of poor secondary wetting, like with nickel gold, for instance. When you reflow, you dissolve the gold into the bulk of the solder, and then you're wetting to that nickel surface. And if for some reason that surface, which is being protected effectively by the gold, is not wettable, then mechanically the solder joint may not be as good as the original. If you're using any solder coating, solder leveling as the finish, then at least you're guaranteed you've got a good solderable finish. And it is quite uncommon to get solder level boards with poor solderability because you've already soldered it once, so that provides a protection to start off with. However, if you have got poor control of your PCB suppliers' boards, in terms of they're not in control of the type of alloy they're applying to the printed circuit board, if they're not in control of the contaminants within the solder they're using to level the printed circuit boards. So all these things need to be considered as well. And also, if you can, introduce some form of solderability test. Some of you may be aware I'm a great fan of the wetting indicator, which is the simplest and cheapest way of constantly monitoring the solderability of your printed circuit boards. And I implement this on any product or any process that I've been involved with.